very good morning to all of you, and happy New Year first day, everyone. So, I just want to know, चालू है how many of you are into the person? You know, raise your hand. सारे के सारे first time लगे थे आपको तो ये हुआ। So, THM and Mumbai, you can see now Mumbai, the chapter started this last year, the same day we have first in 2023. So what we do is every month we organize a conference based on any certificate topic, kind of engaging and kind of data discussion and everything. So till this was that. On the regular till now, we've had over thousands of regular attendees, including the world. We've had 30 plus different speakers come and lecture in the conference, and we conducted 11 plus events for this year. So, finish your guys. So, calling up our first session. So, we have basics of blockchain security by enthusiast. Good morning, one minute. Good morning, one and all. I am Ishan Lokhande. I am currently the acting chairman of Lokhande Foundation, and I am pursuing my research master's from University of Edinburgh in computer science. So I'm doing specialization in blockchain, and I'm here to present a very short presentation on blockchain security and further opportunities. So before moving on, we would just have a gist of what blockchain is and what its core components are. So So first of all, let's have a brief definition of blockchain. The blockchain is a decentralized and distributed ledger. So when we say decentralized and distributed, it's nothing but it has no central node. So when we talk about a traditional computer system, we have a server, right? We all communicate through servers. Like if you are texting to your friend, it has to go through a server. In this case, there is no such thing as a central node or a server. We directly communicate to the peers, or in traditional or layman's term, you can compare it to peer-to-peer network, right? The concept of blockchain is based on network of computers directly connected to each other rather than indirectly. As I said, there is no server or central node present in this network. So blockchain security, as like since we are having the chapter, the name of the student chapter is the hackers meet. We have to talk about security, right? So in blockchain, in the world of blockchain, security is the we can say it has the most amount of focus out there. Unlike when we talk about central, we have some components of security, we have some components of back end, front end, and then we have cyber security layers to protect us. The entire concept of blockchain is based around security. We have to validate each and every transaction out there to perform it. We have to, like what we can say, like if you're even running a simple code, we have to check whether it's according to the compliances of the blockchain standard. So some cryptographic principles, or we can say the core principles of blockchain security are hash functions, digital signatures, public key cryptography, smart contracts, and consensus. We'll have a look at each of this in detail in the upcoming slides. But let's just have a brief one. Hash functions are nothing but the hash values and like how they are stored in the blockchain. Digital signatures, we are pretty much familiar with like everyday digital signatures we have around central nodes. Then we have public key, pretty much the standard public key, except here it is done in terms of ledger and delegates. We have consensus. So there are many consensus algorithms, but mostly we have proof of work, proof of stake, and delegated proof of stake as consensus mechanism, and smart contract security. What smart contract is, it is a set of instructions that has security measures inbuilt into it. It does everything from start of the transaction till the completion in one go rather than our normal code work. Like we need to first take the input and then process it and then pass it on to security for another program. Blockchains don't work like that. We have to make the smart contract inbuilt with the security measures. So the key security features, of course, as we mentioned, there is consensus mechanism, and then we also have immutable nature of blockchain. So when I say immutable, the reason I say immutable is there are n number of blocks because each transaction will generate a block. So for example, if there are 10 users and 10 users do 10 transactions on my blockchain, there are going to be 100 blocks in a time. So to unlock, let's say 98 block out there, I need to unlock the what we can say 97th block. To unlock the 97th, I need to go back to 96 because I need to know the hash function of previous block to unlock the next block. So to unlock any block out there, I need to know the hash function of Genesis block, which is nearly impossible to backtrack. Considering like each and every transaction makes one block, and some transactions even generate two or three blocks out there, depending upon the size of the transaction, it's nearly impossible to trace back the Genesis block and get its answer. So the common security challenges that we face out there are quite different when it comes to blockchain. We have 51% attacks at double spending risk and smart contract vulnerabilities. So when we say 51% attacks, so consider like a best case example for this would be having a majority in a game. Like consider you're playing a game where everything depends on majority. If you have a majority, you're gonna win. Consider elections. If you have majority, you're gonna win the election, right? So if a person holds more than 50% of the blockchain network, he has an unprecedented authority over the network and can control the entire blockchain. Not entire, but some part of it which can influence the other networks. So that is vulnerability. Then we have double spending. Like when we say about transactions, each and every transaction in blockchain costs some kind of transaction fee. It may be in Ether if you're using Ethereum. It may be in some other token if you're using some other blockchain out there. Then we also have smart contract vulnerabilities. So as I mentioned, smart contract is a set of instructions. We as a human write set of instructions, right? So when we write a code, there are gonna be some kind of oversights that we do. Like you are writing a code, you miss out a quotation. You are writing a code and you miss out a certain argument that you need to put in that needs to secure the data. At this point, even though it's a smart contract, it's gonna fail because you made a silly mistake out there, right? So there are certain things when it comes to blockchain that can affect it adversely. So what can we do to protect this, like not to ensure nothing happens, like to ensure proper security in case of blockchain? So we have, as we mentioned, public key cryptography, digital signatures, hash functions, consensus mechanism, which are of three types: proof of work, proof of stake, and delegated proof of stake. So public key cryptography, it is nothing but a key that each and every computer possesses to unlock a file. That's the simplest I can say when it comes to layman's terms. There are other technicalities when it comes to public key. It has to be registered and everything, as we know. But in case of cryptography, it is very similar, you can say, to the traditional systems that we have to ensure an extra layer. Then we have digital signatures. Of course, we have to currently be digitally sign everything, right? We have e-Aadhaar, right? If you have to remember, you can sign government contracts online. How do we do that? We do that through digital signature. Same way, we also have digital signatures for smart contracts that are need to be signed before putting it out, published, and produced. We also have hash functions, as I mentioned. To unlock any block out there, you need to know the hash function. Hash functions are generated using various algorithms. Bitcoin uses SHA-256, whereas Ethereum uses ETH. Uh, Currently, in under Ethereum, we have Polygon and Solano, which also use ETH Bitcoin hash tokens that doesn't use SHA-256 but relies on other algorithms to generate its hash function. We also have consensus mechanism. So when we say consensus mechanism, what do you see? What do you understand? Like when we say consensus now, it has to be something like when you are doing a transaction per se, you need to have like the what's the proper word? Like you have to have the proper yes from everyone. Let's just say you are voting and you need to have as yes, yes, yeah, it's okay. Go ahead. We have to have the go ahead from everyone. That's the consensus mechanism in layman terms. So there are three types of consensus mechanism. We have proof of work, proof of stake, and delegated proof of stake. So what we will go through one by each of them. So proof of work. What proof of work? Have you heard the mining of the blocks? In Bitcoin, we mine blocks. In Ethereum, we have proof of stake. In Bitcoin, we have proof of work. So what proof of work? It's nothing but solving a mathematical equation in a given time, in a given difficulty. Once you do that, we have proof of work. The reason we not have like we use proof of stake and delegated proof of stake more than proof of work is proof of work takes a huge amount of time. As the difficulty increases, the time taken to validate the transactions is gonna be huge. It's gonna be like currently in, if I'm not mistaken, in Bitcoin, I guess it's around 18 hours on the current level of difficulty. It's 18 hours to do one transaction for a pool of 20 people. To consider, and that do we need 20 distinguished computers to validate the transaction. So yeah, it takes huge amount of time. That's why we have proof of stake. What proof of stake? Consider this. Have you like how many of you trade in stocks? Anyone? Okay, everyone is like financially literate over here. So when you buy a stake, like a share on something on stock market, you get voting rights, right? We don't get voting rights to the board members, but we get voting rights to what policies we have in the upcoming fiscal year, right? So that's your stake in the company, like maybe 1%, maybe 0.5%, 0.1%. So you can like have a say what the company is doing. You can't control it, but you can have a say. It's the same as proof of stake. It's the same as proof of stake. So in this case, you need to have some kind of token with you so you can validate the transaction. Let's just say कि first 10 people have 10 tokens of each. They can validate the transaction if they clear the threshold. Right here, everyone can validate the transaction as long as they clear the threshold. Then we have delegated proof of stake. Now this is where when we talk about a company, let's just say you own a company and there is a board of directors with you. Right now, people will vote. As a shareholder, you all can vote, but your vote won't have the equal value compared to what the vote of a board member will have. Let's just say the value of board member is 10. You might have a value of 1. You might have a value of 0.5. So that's the delegated proof of stake. In this method, we have certain members elected to validate the transaction, which is much more faster than the proof of stake. The reason we have this type of mechanism is to validate the transaction and progress the blockchain, the chain of blocks further, or say to expand the blockchain. What do we have when it comes to future opportunities, right? Like blockchain is still a very emerging. Blockchain is a very emerging technology right now. Even when I'm working on the research now, it's very hard to get any previous material to cite or to see anything. In my 4th year of engineering, I did a research paper on blockchain, which covered peer-to-peer chat network. We had no previous year's preparations on that. We had no papers. We had to do everything from ground up. My colleague over here, Jayesh, was also involved with me. It was a hectic thing. But let's just say it is a very infant stage of its places. So what are the future opportunities over here? We have interoperability. Currently, we have two major blockchains. Everyone knows. We have Bitcoin and we have Ethereum. Bitcoin is also called as dollar of the blockchain. Ethereum is also called as oil of the blockchain. But in real world, dollar and oil are interrelated. If price of one increases, the price of others also increases, right? Here, interoperability doesn't exist yet. There are some places where you can find blockchains interlinked. Like there are a few places like token creations where you can link to blockchains if you have the capabilities. But there is no such thing as definite interoperability in cases of two different blockchains. Then we have decentralized identity. So let's just say you are a validator in proof of stakes consensus mechanism and you're validating transactions. How am I supposed to know that you are the person that's validating the transaction and not someone else? Right. We do have some kinds of private addresses that we use to authorize people. But the problem with private addresses is once you change the system, you change your private address. You might lose your proof of stake over there. So that's one of the problems. Yeah, Ethereum has got it sorted right now. They do have dynamic private addresses that change once you change the system, but you have username and login with them. The best example I would give of decentralized identity would be MetaMask wallet. You create an account, you get maybe like let's just say you create an account and they give you some random phrases that will validate that you are the person, and then they generate your private ID. Once your private ID is generated and you shift the systems, let's just say you change system from system A to system B, and you have that phrase. Once you put in that phrase, secret phrase, you will get a new private address, but you still have your proof of stake in the system. You don't lose it. Then we have governance model. Like recently when cryptocurrencies were in boom, remember like how China and USA started imposing taxes. Even Indian government like impose taxes on cryptographic gains, if I remember. So yeah, there are few governance things that are happening. People, like governments and everything, need to understand how blockchain works, because once a transaction is validated on blockchain, it is really hard where it is originated. We do know what the smart contract has done. We do know where it is executed, but we don't know where it came from and where it's going. That's only known to the ledger, and ledger is completely hidden from everyone, including the authorized person. Ledgers are auto updated, and every person who is on blockchain has a copy of that ledger. So it's not like you can, okay, I have 5 Ethereum, I'll update my ledger to 500 and I'll have 500 Ethereum. No. Each and every person in the blockchain will have copy of the ledger where they will validate your transactions if they are true, right? Then we have integrations of blockchain with other things. Of course, let's start with the most basic Internet of Things. Have you ever heard about there is something called as dot on blockchain? If you go through Tor browsers, you can access dot. Dot is something which is developed on blockchain, running on central web, and it can do things none can imagine. It can let's just say it's Alexa on steroids. You ask Alexa to turn on the light, it turns on the light, right? But you can ask Dot to do everything, literally everything, including writing your prescriptions, including booking your appointments, including booking your flight tickets, to the level of having your toilet seats controlled with it. So it's pretty neat, but like we are still in the very early stages of it. Then we have artificial intelligence. Of course, when we talk about IoT, AI comes in. You like everything is smart right now. When let's just say, like how many of you are working right now? Office, right? So when you go into the office, you punch your thumb or your card to get in, right? If I'm not mistaken. So that's IoT. But currently, you can also do that in few places. You can also do that through faces. That's AI. That's integration of AI to IoT. Same thing you can do with blockchain. Here, the data is not stored anywhere. It is processed directly through the ledger. That's how AI works. Sorry, blockchain works in AI and IoT. Of course, when it comes to cyber security, it's gonna be large. I'll just cover the gist of it here. In terms of cyber security, as I mentioned, it's pretty much immutable and everything. There are certain layers of blockchain that you need to penetrate to get to the very first layer where you can access the data, which is nearly impossible if you don't have the Genesis hash function. Even if you have the Genesis hash function, it's going to be very difficult if you're trying to decode an nth block, because you need to know hash function every other block. So in terms of cyber security, if we are able to integrate, it will provide a huge boost, because let's just say currently we have secure mechanisms for transactions, right? Where there is something now, Visa cards have launched where they mask your CVV and card number and replace it with some bogus numbers for your transaction. But in terms of blockchain, you don't need to store it, right? It's already been somewhere in the blockchain and no one knows where it is. No one can access it. So blockchain provides a sense of security which our central nodes can't provide. Double spending problems and everything. Yeah, double spending problems when it comes to double spending problems in terms of cyber security and blockchain. Cyber security can prevent, currently cyber security can prevent double spending problems more accurately compared to what blockchain can do. We are, like, not me as such, but like other researchers are currently working on how to minimize those risks, because when it comes to transaction and transaction fees, Ethereum is one of the most expensive places you can use. So, and as we mentioned, cyber security is a very huge topic. But in blockchain, when we compare it to blockchain, like anything integrated with blockchain will have its own advantages compared and its disadvantages. Let's just say we integrate cyber security with blockchain and somehow we maintain that second double spending problems integrity and somehow we introduce ledger to it. It's gonna have that hint of how do we identify who is doing the transaction, because in blockchain every other user is unidentifiable until they have the secret key, right? So that's all for blockchain and its security and future opportunities. If you have any questions, please go ahead and ask me. I'll happy to answer. Yeah, go ahead, please. In proof of stake. So in proof of stake, they don't have reward system because you already own the type of token that they are rewarding. In proof of work, we get rewards. Currently in Bitcoin, it's for 18 hours of work, it's 6 Bitcoins that are divided among 20 people. So it's point something you get for every mathematical equation you solve. The background. You're working or are you a student? मैं उसी आपसे सवाल समझाता हूँ. Okay. You're a student, right? Consider this: you're in college and you're voting for your class president. Okay, you have some stake when you vote, right? You have, like, let's just say vote count as one. Your vote what count, everyone voted and person A wins. That's proof of stake. In when you get a proof of stake, you can't vote. Your teacher will directly come and say, okay, yeah, this is the class president. She has all the rights. She has the authority to validate the transaction. But it's not just one person, it's a group of people, like board of directors in a company. Or the best example would be Indian democracy. How we elect our prime minister. We elect MLAs and MPs, right? We don't elect our prime minister directly. We elect MLAs, MPs, and then they elect the prime minister. Indirect democracy. So we are the proof of stake. They are the delegated proof of stake, and they are validating a transaction, that is the prime minister. Has anyone else? Concept of smartphone. Yeah. So it is easily here in the no, it's not like that. Okay. Online has something inside my I'll get that. So yeah, your doubt is kind of like what I had when I started using blockchain. So when I started doing smart contracts, I started what I'm doing. It's like what I'm running on my system, Python, Java. But the thing is, smart contracts can't run on their own. They need to have some kind of uh, access to the mainnet or testnet where they can update the ledger, right? Let's just say like how Python runs on Python compiler, Java runs on Java compiler, and C runs on Turbo C. So Java, like smart contracts are not universal as such. Ethereum smart contracts will run on Ethereum. We have languages like Solidity, Viper, which is derived from Python. So if you have if you are very good with Python, I would suggest run Viper because it will be easier for you to understand. Then we have Solidity, which is closer to Java. If you are very good with Java, run Solidity. So what happens now when you write the set of let's just say when you write a smart contract or the set of instructions, you have something that you mention on the top of which is called as SPDX license. You have Pragma Solidity and the version of Solidity, and then you have all those arguments going out there. There are certain arguments that you need to add that connects it to the blockchain, to the testnet. So once you run it now, and even when you run, like when you compile, that compile the time that it takes, even that generates a block in blockchain. So it tells everyone, okay, this program was compiled, then you deploy the contract. So now this contract was deployed, and finally when you do transactions or when you run the contract for its output, Now, okay, this contract was run, this was the input, this was the output, this is the hash. Now, if you're using Ganache, you can easily view everything, but like there are certain hard hat testnet which tells you what kind of block was generated, why was it generated, but that's on command line. Ganache has an UI. So it's easier for beginners to understand Ganache compared to what hard hat. Private blockchains you can't view, no? As I said, not even authorized person can check out what's happening inside. But that's the whole point of blockchain security. No? It has to be more secure than what our current system is. That's the reason government is hard on hitting on blockchain, because you have no access to know where the money went and where the money came from. Let's say I buy 10 Ethereum in Ireland and sell it to someone for double the money in India. They don't know where it came from. They don't know where it is going. They just know it happened. Who are you going to tax? That's why government is hitting hard on block. I guess India is a 50% if you have gains above 1 lakh or 10,000. I don't remember the exact number, but it's 50% of the whole amount that you get on the gained amount, not the principal amount. Sorry, sectors implement blockchain. See, as far as what I have known, because I'm still learning about blockchain. I'm still a researcher, right? There is so much to learn. But when it comes to where we can't implement blockchain yet, would be banking, because as I said, double spending is an hard issue to tackle on blockchain. No, like let's just say that 51% attack. 51% attack is a type of attack that happens on blockchain when you own 51% of the block. Right? Yeah, yeah. You have the whole and soul, like you own that blockchain, right? You can influence each and every decision that happens in that blockchain. 51%. So now consider this: if you own 50, Twitter is a fiasco. Everyone knows, right? What happened with Twitter when Elon Musk bought it. So there is this threshold of 9.99% that you can buy of Twitter. You need to own 13.9 and above to have a direct say or control the entire company. When Elon Musk wanted to buy 13.9, so let's just say 14% of the company, they swallowed a poison pill. Poison pill is something which allows them to not sell any more stocks, right? To protect themselves from Elon Musk dictating their rights. But then again, Elon Musk came in, I'll buy, like, he was like, मैं पूरा cash में खरीदूंगा. He bought the whole thing. And now he renamed Twitter, what everyone knows the new name is, I guess. So that happens when you have no accountability for your actions. Na, people like Elon Musk exist. Last month. Now, hmm? See, proof of stake is something, as I mentioned, you need to own that token. If you don't own, you can't validate the transaction. In proof of work, you just need to have the computational power to solve it. So everyone can participate in proof of work, but not everyone can participate in proof of stake. So when it comes to participation, proof of work is much more scalable compared to what proof of stake is. Time, of course, proof of stake has better time complexity compared to what proof of work has. Then we also have something called as I mentioned, delegated proof of stake, which is a higher end version of proof of stake, where everyone has like an authorized person can only validate a transaction. Here, if you don't have the authority, you can do nothing over there. So it is much more, it is much less scalable than compared to a traditional proof of stake. When it comes to participation, proof of work has more scalability. When it comes to work, proof of stake, like time consumption, proof of stake has more scalability. And like in what other terms can we talk about scalability? Let's just say ki you have money but you don't have computational power. You're better off proof of stake, na? But you have computational power, but you don't have money. You're better off with proof of work. You can even earn money with proof of work. You get paid for proof of work. You don't get paid for proof of stake. Uh, yeah, exactly. So proof of work, as I said, you get paid for the work you do. You need to mine the block. Yeah. Sorry. No, it's like when it comes to blockchain, na, each and let's just say there are 10 transactions pending. Each group gets one transaction, and it's not like the person who solves it gets the money. No, the entire computational power is brought together to solve that one mathematical equation, and that money is then equally divided among the participants. Huh. Hmm. Yeah. Hmm. I have sorry. See, I have not heard about proof of stake working with proof of work as you mentioned. We need to mine and then have the stake in it. As far as like I have read, because I don't work on proof of stake, I work with delegated proof of stake. Ethereum, I guess, was proof of stake before it went what you said, right? If it went with proof of work, I still have like I will get back to you how it works along with that. Yeah, yeah. Maybe that's the case. I have not heard about it right now. I'll get back to you. Huh? Sorry, किसको? Any more questions, guys? बंद क्यों करके देखता है? Any more questions, guys? Thank you. Okay. गर्मी होता है भाई होने से पड़ रहे होंगे
company where I work. Let's talk security blockchain. Okay. So what I try to do is I try to divide this entire talk into three sections. First is little bit of understanding what blockchain is, how the architectures look. Secondly, we then dive into what are the challenges currently and what are the security incidents and issues that is happening. Try to understand the attack surfaces. Basically, what are the points which are exploited by the attackers to enter and exploit that. Okay? And then there will be a little bit of a bonus cycle where I'll talk about what are the current security exercises that cover blockchain spectrum. Okay, so as you know that you have private blockchains and you have public blockchains. Okay, so depending upon mostly enterprises work with private blockchains so that the friends who you work together, but we're trying to work generic. Okay, so if you have more questions and feedback changes, then let's go through all those things. Okay, let's go. Okay, so this will be the flow. Starting with understanding the blockchain, what the blockchain is, structure, and some security incidents we'll discuss, and then what does the future of blockchain look like, and how can we secure the blockchain. So let's go. Okay, so like Ishtar mentioned, blockchain, I'll put it in a different way, I would say. Databases, right? We all work with databases. So let's put it in a way that blockchain is, you can say, database. Okay? Every database is a database. So what happens is that it's a transparent database, which everybody can see in the network. What transactions are happening, whatever is there, it's present. So it is a digital block, which securely records the data, and it is unpredictable chain in theory. Okay? So it is a ledger which documents all your transaction data, whatever you want. Simple. Let's move on. This is the process how blockchain works. You want to add?
Just a second, just.
Yeah, so a transaction is requested, a block representing the transaction is created, block is sent to every node in the network. Nodes get validated, and the nodes are moved.
Next.
Yeah, the transaction is completed and the block is added to the existing node. So this is what basically how blockchain works, and I'm assuming that you understand how the technology is. I'll not spend a lot of time. Let's move inside. Next slide. These are three pillars. You need to understand why blockchain is considered secure. First is that nothing is centralized. Everything is spread across. So that is one pillar, which is decentralization. Second is transparency. Whatever happens in a network, everybody can see. Nothing is hidden. Everybody can see that. So that's the second pillar. Third is immutability. Once the change is done, you cannot change it. So these are three pillars which make blockchain in theory secure. Okay? Let's move. Okay. So each block in a blockchain, I'm not sure the image is clearly visible, but each node in a blockchain network looks pretty much like this. So if you closely look at it, you have uh, you have block header and then you have block body where the data is stored. Okay, and in the header part you will have the hash, version, launch, puppetry, and all those, versioning information related stuff with the header part. And in the data part where you have the required transaction data present. Okay? This is how typical structure of a blockchain looks like. Next slide. Okay. Now, when you look at this, I'm not sure how clear it is for you guys, uh, but what I'm trying to present here is two different phases of technology. So one side, on the left side, you have Web 2.0, what we currently use. So whatever technologies that exist in there utilizes 2.0 mostly. And this is how you have the three-tier architecture. You have the front end, back end, and the database. And here comes Web 3.0, which talks about blockchain technology. Okay? So if you look, the front end still remains the same. So you still have whatever your front end is written into React or whatever it is, it's still in place. But if you see the back end in the database is changed, you have smart contract, then you have Ethereum virtual machine, and then you have blocks. So when you look at this image, you're a security professional, what goes inside your head? You try to analyze these attack surfaces. So for us as a security professional, all this thing is an attack surface that we can exploit and play around with. So whether it is a smart contract or a virtual machine, so they themselves, for example, a smart contract, which is written in Solidity, uh, there can be multiple static vulnerabilities inside that code, right? So that becomes a attack surface for us. So that is where enterprises work around securing those areas, the smart contracts. Then you have Ethereum virtual machines. Virtual machine can be from any protocol out there. You guys know there are multiple protocols present. So you have virtual machines and then you have blocks itself. So this is how a typical architecture of a 3.0 network would look like. So it is very simplistic view, but there is an advanced version of it. Next slide. Okay. Look at this slide. What do you see? Still, you have the backend part, you have the front end part, but there are some other components involved. You have an IPFS, interplanetary file system, or swaps. These are you need to store some of the static content or whatever you want. Then you will have the providers like LKB, MetaMask, and all this. So your front end needs to communicate with the back end, right? So how do you do that? Either you have some APIs to communicate with these two. Let me know if it is going above the header or anything like that. Okay. So we'll take questions at the end of this. Okay. So this is what in depth architecture would look like. There are multiple other components, but in reality, if you try to decompose from a security person point of view, you have a front end, you have some APIs, you have a back end, and then some other components involved. So that is how we analyze the attack surfaces, right? So how are we securing this? If these things are not secure, then it becomes can be a potential vulnerability for us, or some kind of a issue in the near future. If it is left into its default configuration, whatever. Let's move. Next slide. Some of the use cases of blockchain. Uh, so why there is a necessity to put cybersecurity or security around blockchain? Because the use cases that you cannot imagine. The use cases can be any multiple. So some of the examples you are listed. For example, if you see we have digital rights, wager, equity, private markets, debt, crowdfunding, derivatives, voting, global payments, e-commerce, P2P trading, multiple things, debit, or decentralized finance. That is very booming right now. So you have a lot of use cases for blockchain. So that itself gives a larger, broader, surface for a cybersecurity guy or an attacker to work around. Okay, so there is a motive for an hacker. It can be from finance perspective. It can be from manipulating some governments. It can be anything. So there's a motive, right? There are a lot of things that are present out there. There are a lot of news that you might hear. So we have put something in the slides in the component slides. It talks about what are the challenges and what are the major issues that happened recently. Okay, so I'm not sure why these two are not visible. These two points are
Color
not visible.
brightness. Color brightness.
Yeah, some collaborative or something, but basically it talks about what are the security incidents that have recently happened in 2023. So basically, there are multiple things which we get to know, there are a lot of things we do not get to know. So they are just right across. So I am assuming it's like 10 billion plus frauds that have happened around blockchain. Some of them are reported, some of them are not reported. So this is what is an accounted number. So this is some news that also talks about what are the issues that have happened. So like I mentioned, a lot of things get accounted that don't get accounted. We do not know what is happening behind the picture. Because the overall reason why we use blockchain or cryptocurrencies is to hide. But even if you use that for that purpose, if you lose things, there is no accountability, nobody is going to ask about it, and it's just lost. It's hard to recover those things back. So all these factors, put in place, it, puts a need for security into blockchain. So talking about all these incidents, there are a lot of enterprise-related incidents have happened recently in 2023 and 2022. A lot of enterprises they talk about it, a lot of enterprises they don't talk about it. They don't talk about it because that will be an issue for their planning, right? And they try to suppress those news. So there is reason why we have to, as a community, put that inside our mindset. What is next? Why we need to work around with the codes, or blockchain? But that is the future. Within like sooner or later that is going to happen. So that is what is about the security incidents and the necessities. Okay, so what are the security challenges that are currently there? I'm sorry about it, but a lot of content is missing. But I'll try to read it for you. So these are some key challenges in blockchain from the security perspective. For example, 51% attack, like it is an attack for dominance. Like you want to gain the control of the network, right? And you want to one of the simple, why an attacker would want the 51%? Why he wants to do 51%? It's pretty straightforward, right? You take over the network, you do whatever you want. Right? So you must have heard about soft forks and hard forks that happen in blockchain. So that is one of the primary reasons why we do 51% back in the network because it needed a different branch altogether of a given protocol. Okay. So second is smart contract vulnerabilities. So this is very much around the solidity contracts in Ethereum. And if you go around into different Electron, Polkadot, Ripple, so these are different blockchain protocols that exist. So you have different contracts written in different languages. So the vulnerabilities of the smart contracts they go unaccounted for because nobody was auditing those contracts from security perspective. Like when we write a normal code, we do SAST, static application security, right? So we don't do that. I mean, there was no practice around it when blockchain came in. So a lot of these code had some inherent vulnerabilities in them, which never got accounted for. So that is one thing. And third is about private key security. So blockchain is all about keys, misplaced keys, lost keys, question phrase is lost, lose them, it's gone. Even if you don't store your keys properly, they get stolen. Something happens. So managing the keys become important. So that is the third challenge. Then you have fourth, the cyber attacks. Cyber attacks talk about creating cyber identities, basically fake identities in a network. So you are trying to create multiple fake identities in the network and you know, enforce or will over the network. You undermine the already established mechanism that is there in the network. So that is what the cyber attacks are about. And you have the routing attacks, the time jacking attacks. So this is one of the routing attack is all about trying trying to make sure that certain group of participants in the mining process do not get participate in the network. So it is an ISP level attack where you try to do an attack on the ISP to suppress to bring down the uptime of the network. Okay, so that there is no uptime, nobody is going to participate in the mining process, right? So that is what is routing attack. And you have time jacking attacks where you manipulate the time counter and you make sure that you are adding new nodes to the network with a manipulated time. And then there is the biggest problem, which is scalability versus security. The biggest any security professional knows about it that performance in security is not going to be. So if you do something in security, performance will get impacted. If you increase the performance, something will come from security perspective. So they never go into it. So all these challenges, present in blockchain, brings a necessity to, come up with a focus on, coming up with a lot of, from the manpower perspective, creating tool sets that will work with, blockchain technology. So that is a requirement, that is a necessity to come up with. So these are the reasons some of them I have tried to highlight. There are most of the things which I cannot cover in a single slide, but there are things. Okay? So that is something about security challenges. Okay, let's talk about the attack surfaces in a little bit in depth. End user wallet, a very common one, which I have heard about. A lot of attackers will target the end user wallets. Because it's very simple, we do those things, right? So, social engineering, phishing, can be any way of exploitation. So that is what exchange platform. I mean, I don't have to dive into that. FTX, Binance Exchange, you have heard about a lot of attacks happened recently in these exchange platforms. Smart contract one already spoke about consensus mechanism. So 51% attack targets the consensus mechanism. You have network nodes, node-based attacks. Like cyber attack is one of the attacks where we try to create false nodes. Mining tool risks, APIs and integration points. We do not focus a lot about APIs, but APIs are one of the very key aspect of security. Even today in the web world, web 2.0 world, APIs, lot of time we do not validate them properly. And some of the other vulnerabilities they come up to our API. So, auditing the API is very important. So that is one attack surface, we miss on. Then you have blockchain forks. You have soft forks, you have hard forks. So obviously they come from their parent protocol, but what happens is that some of new changes are introduced into them. So they get differentiated from their parent protocol. So there are a lot of vulnerabilities which come into them. People don't take up, or the community which is maintaining those modules or the libraries, they don't patch them with a proper security patches that is required. So there is a need to work in the DevOps area as well. Then we have infrastructure. So when we talk about private infrastructure, so what happens is a lot of time people are not covering properly. So either there is no enough, not enough good skill set present to cover all these things, or just because of the budget constraint, a lot of companies are doing work on this. So infrastructure is another big endpoint, which becomes a target. And then you have user interface or the UI. This is pretty straightforward for you guys to understand. CSR, XSS, the common vulnerabilities and target. Because if you remember the web 2.0 versus 3.0, the front end is still the same, right? So still the common vulnerabilities that apply to 2.0 will apply to 3.0. So that is there. Next slide. Okay. So what is the future? What will change in blockchain security? You might not know, but there are a lot of things that are still being worked on. There are companies who are already working on certain technologies, which is way ahead of the time. During my time into one of the big consulting firms, I came across a team which was very specifically working into an area that had a claim, I'm not sure what was the proof of it, but they were using quantum computers to break their head. So for us, it was not to believe, but it was happening that time. I'm talking about a year back from today, or something like that. So you can just imagine. So what we are trying to do is, companies are there, companies, people, communities, they're working on developing quantum resistant algorithms. Because your computing power has gone insane with quantum computers, right? So there is a need to develop quantum resistant algorithms. Second is smart contract security. I cannot put enough emphasis on this, but smart contract security, when a developer writes a code, at that very moment, you need to work on this. It has to be worked around that time itself. If you go to the SDLC reasons, I'm not sure how, see, you have secure SDLC, right? So in secure SDLC, what you do is you follow left shift approach. The goal is to put security at the earlier phases, right? So when you go on blockchain, you have to follow a similar approach. You have to bring security right from the requirement gathering phases. So what we do is security requirement gathering at the phase one, then at the design phase you do certain exercises, which is security architecture you brand model. We'll talk about this later. But you have to bring all those practices in place. Unless until you don't bring it in place, you cannot secure it. Then now this decentralized security models, this is very much from the identity perspective. Use it to improve your applications. What is who is accessing what is required? So you have to have a focus on identity and access management part as well. Right? So and third and fourth is last, which is standardization efforts. So when things are open source and it is spread across, there's no standard which is across all the on an entire platform. So there's a need to put a standardization across the platform so that everything is into a similar requirement. Why enterprises do that is sometimes is that there is an effort to regularize and standardize everything. Right? You have a process and policies that is followed. So some kind of an initiative from the community perspective is required to standardize the entire platform. Right? So it can be from the moderator perspective or who is the admin of maintaining the repositories and to follow those practices and standardize you want to see. So so that somebody does not come up and write some different piece of code which generates some different outcome and then implementation. Right? Next. So what is the key takeaways? We know that blockchain has its inherent strength, right? It is inherently secure when compared to traditional technologies. But there is a need because security landscape keeps changing, right? So we have to evolve around that. So that is important. And it is a responsibility of the maintainers of the repositories or the libraries that are present on GitHub or wherever it is present. You have to maintain those things. You have to make sure you have proper controls in place to make them, standardize those things and everything is, in proper processes for monitoring problem. So that is a big. There's something which I would like to put with you, which is a bonus slide section that will help you to gain insight what is currently done in industry to understand to secure blockchain. Move it. Okay. So there are a couple of things, or you can say a couple of activities that every enterprise does it. So you have a secure code and smart contract assessment. So what we do smart contract audits. Okay, this is like a SaaS, a smart jargon you can say, or SaaS. This is then SCA. You must have heard about software composition analysis. So so when you develop any application you utilize or any technology you develop, there are a lot of open source components. What happens is that if there is a vulnerability in those components, it goes at a component code. So you need to stand and find those first to fix them. So that is what we do in this software composition analysis. Then you have node and infrastructure assessment, where you do blockchain virtual machine review, you have blockchain code and network security assessment. Then we do container security reviews. From the business, the app perspective, basically when you have the app developed, we do ELPT. So to provide an end-to-end coverage from the business logic perspective, so that everything is covered. And then we do gas tags, that is one of the technical things that is going on. Then we have the security assessment as part of the audit. And then you have blockchain architecture review. So what we do is threat modeling exercises, blockchain protocol audit, open design review, and cryptography implementation assessment. That is very much around, I would say, private key and all those things. So this is what is currently there in industry. This is what is best there in industry. Apart from this, there is no other assessment or services the companies can do for you. Okay? So these are some tools that this I wanted to present to you guys, people from security community, they know about also. So these are some tools like consensus, Apex, solidity scan, agents, Wither, Securify, Octopus. So these are some tools that which you guys can utilize. For example, Linux is one of the paid tools I would say to perform smart contract audit. Meetup is open source. Okay. Also, is when you can evergreen when you do a business, logic, and time if you want to find all the things. It will help you. So this is all about the tool set that is present. There are a lot of more. I cannot cover it into a single slide, but my goal is to create that enthusiasm in you guys so that you go and explore these tools, to work on it. And see what these things are. There are a lot of opportunities to come up with new businesses in favor from the security perspective. So that is what it's all about, why there is a necessity to take security into the blockchain. That's it from my side. And I'm happy to take other questions about it.
Thanks, so it was a very insightful session. The way of conducting, the way you explain different areas, those are insightful. Thanks. My question is based on the regulations. So you already mentioned that emerging frameworks and regulations are on its way. But as of today, what is your preference? Do you have any regulatory draft frameworks or any frameworks which you guys refer to? Because I mean, at the end of the day, you have to apply somewhere or the other.
Okay, so the question is that do we have any regulatory frameworks or not? To be honest, I have not come across any standardized regulatory framework. Or I would say nobody's following this, even if it exists on common. So that's the reason we need to have that something to control entire, or to standardize everything in a proper manner.
have really enjoyed the presentation. So I have two questions. Is role-based access control also a part of security systems that we saw in the third last slide? And my second question is, how future-proof are the security systems for blockchain that we are laying right now? Like, are they really future-proof? Because by 2030, researchers are expecting that we'll have quantum computing in 100 devices. So those 100 even strong RSA encryptions and RSA algorithms. So how future-proof are the systems that we are currently laying down, let's say by 2030?
So the answer to that question is like, first is that you asked about role-based access control, right? You have versioning controls, so right, you have your GitHub repositories. One of the standard practices to secure your repositories to implement role-based access control. Yes, that is one of the mechanism to control your repositories or internally within the organization to also follow this archive. We follow archive. If you want to restrict access based on the rules. Second question, are we future proof? So like I mentioned, we talked about that incident where internally there were companies who are working on developing enough computing power to break the hash, right? Or create an hash which is equal to what from the data input data you can create the hash, right? So you can do that. So there is a mechanism, there is enough computing power present that can do that. So I would say we are not future proof unless wake up and we need to start working in terms of blockchain. Definitely not. Any more questions? Okay. So I put workflow for a reason. So one of the common the way you develop, one of the common technology stack is web applications. Then you have your mobile application. How would a common user interact with an application, right? Either through a web application or through interact with any kind of technology or any kind of application via some kind of interface. Right? So suppose it is a web interface, you can use WebSocket. As a security professional, you can put your proxy in place and start analyzing what request is going on. You can see what are the backend details user. You can discover a number of things. Even in case of mobile application, you can do that. Right? You can do SSL like that, right? So that is the reason why workflow is going to be there. I mean, as long as we have web applications, mobile applications in place, or end user applications of blockchain, so workflow is going to be role. So, for example, I will just put it into a picture. For example, here you want to do first. Well, professionally, you get a lot of payrolls, right? You can suppose in the back end it is running Ethereum virtual machine or it is running Ethereum protocol, but the front end is going to be pretty much like you will have certain query parameters, you will have certain string. It's all going to be there. So how do approach those areas? Workflow is going to be one of them. You can use Zap as well. There's Zap. Any more questions?
Can you give an example on civil attack and explain more about civil attacks in blockchain as well as in cybersecurity?
So, example of civil attack. Um, I would say not. I mean, there are multiple things outside in the market present. A lot of proof of concepts are there, but there was an exercise that we talk about doing. So how attacker thinks. So basically, example of civil attack would be simply, for example, you are a user and you have your network in place. For suppose an example, it can be an enterprise which has its private blockchain network and everything in place. What happens is that you have your identity in that network, or it can be a consortium of banks working. And there is a common blockchain network which is shared on that. So what can happen is that somehow some attacker enters into that closed circuit of banks, and it utilizes the identity, somehow it gains the identity of one of the bank. What it does, it creates the same identity with multiple inside the network, multiple identities of the same node within the network. So what happens is that you gain the port majority control. So whatever is the protocol and the consensus mechanism in place, you override them once you have the majority control. So the way a single attack would work is a complement with a 51% attack. So that goes in hand in hand. So your goal is to undermine the authority of whatever consensus mechanism is there in place. So that is how it
So
works.
how can you prevent such attack like in blockchain? Like
Okay.
I can give a thing like in MetaMask, as previously Ishan said, we worked on a project where if we log on a MetaMask wallet, it would not allow us to make a fake identity. It will like just sign it out and then log in over the other device. So how can you prevent that in
Okay.
blockchain?
So
Except not
yeah.
using MetaMask wallet.
So the answer to that question lies into implementing the controls of this. So any attack does not happen. It is a combination of multiple attacks. For example, it can be a social engineering attack, it can be a phishing attack. So you have to cover all the services. When you come to a very unique set of questions that you ask it. So you can implement, authentication mechanisms where you are checking the state of user login state. Okay. So you cannot allow multiple identities for the same user. You can restrict that. Okay. So the implementation mechanism can be anything, but that is one of the way to do it. I would say. Any more questions, guys? Okay, guys. Thank you. Thank you so much for listening.
Okay, this sounds better. So let's begin. Yay! So AI is an interesting topic. Like, from 2021 onwards, there are a lot of things. Like, there was first the wave of GPT-2, then there was GPT-3, Chat GPT was launched, and then was a lot of competition in that. There was, again, after Chat GPT, Llama was launched, the Microsoft's open source model. Then there was competition from Google also. They were like, okay, our competitors are building some AI tools, we also have to hop in because हमको क्या करना है हमको बस कंपटीशन करना है राइट so they introduced Gemini, and then they did a basically they made a fool out of people. They launched things which they were not providing. Right? If you have seen that Gemini wala video, you would have understand that they were creating an illusion. Right? So there was a lot of things, and in current to 2023 last year there was LLMs, boom of LLMs, and now there will be a boom of LAMs. That's large action models. So continuously AI is progressing and the domain is expanding. So why not integrate AI into security? Because it's the need of our right. So about me, I am Pratik Shetty. As already they have introduced me, like I'm an AI developer at Chums AI. So we build a character AI where people can create their own avatars, chat with it. So it has a personality of an own. And I'm also a part of PCT open source where we would build open source tools like Linux related tools and then ERP and more utility. Also, I'm hosting a community known as Genosis X. So yeah, that's about me. So, what are today's objectives? So, after this session, there will be three key takeaways. You will be learning about how AI and security go hand in hand. You will also be learning about some good open source tools which are growing. And most importantly, you will be learning about how AI can effectively counter cyber security threats. And also, what are some drawbacks? Because like everything has some percentage of drawback, right? So let us do a drill.
You might have heard about deepfakes, right? Do you guys know what deepfakes are? You might have recently seen it in news. There was a deepfake of Rashmika Mandana, right? And it was like it's different for morphing. People generally misunderstood morphing and deepfake, but deepfake is a more advanced version of it. So basically, there's an algorithm known as generative adversarial networks. It's a deep learning algorithm. Basically, what it does is it's built of two networks. One is a generator, one is a discriminator. So from the name itself, generator generates images. So you pass on a array of data and to the generator adds some noise and manipulates the image, and discriminator's job is to discriminate between the original and the fake or generated image. So this is like a drill, as in the drill between virus and antivirus. So they both keep on competing with each other, and thus generative adversarial networks main concept is like enhancing the model through this constant competition, right? So it's very difficult for human eye to interpret a deep fake. So that's why we need AI or deep learning algorithms which can do this task more efficiently. As you know, in traditional security, like there are a few drawbacks. Like this meme right here. This is a very famous meme, right? Like, what is AI? People will like, okay, it's just an if else conditional or a very big if else conditional, but that's not true, right? AI is very vast, and like if we talk about specific use cases, like AI can be considered as supervised learning, unsupervised learning, and reinforcement learning, and there are more types of learning. That's a part of ML also. So like AI is a wide scope of that. So there can be clustering, then there can be reinforcement learning, wherein like you constantly adapt to the system and identify different types of threat. So why it is more preferred? Because the traditional things, it's a basically rule-based thing, right? You have specific preset of rules, and if, for example, there's a malware or virus, you go through that set of rules. If it matches, you detect it. But what if it's just a benign, like it's not a malware? It might falsely detect it, right? There might be false positive. So it needs to be more proactive in the sense it needs to detect things that are outside of that rules, right? Because hackers or like cyber security people keep on constantly adapting to new things, right? So they won't be always launching a similar type of attack. So what if the changes are there? How can the system adopt? In traditional system, you just have to keep on adding rules. But what if we integrate AI into it? It can proactively do this task, right? It can basically detect new type of malicious attacks or new types of patterns from the previous patterns. And this is where the main agenda of AI comes is like as it is more proactive, there are chances that it can detect things like zero-day attacks or exploits, which are not detected by traditional approaches. So what can be done is we can add AI on top of these traditional approaches. So where both can go hand in hand. So AI is a game changer. How come it like has a real time threat detection? It can automatically respond to attacks. With the help of AI, you can have systems which can flag or directly block such malicious attacks even before manifesting into something big, right? So that's where prevention comes in. It can do predictive analysis by being more proactive, as in like you have a lot of data of these attacks. It can dig into it with data mining, get into patterns, and if next time some attack happens, it can actually detect the previous pattern and enhance it and can stop that attack. So predictive analysis. So it mainly has some key factors like AI is analyzing the behavior of the attacks, and it gets some key features from that. It, it has some algorithms like dimensionality reduction, wherein which it extracts the key features and then it analyzes those features. So the next time any attack is happening, maybe backdoor access or anything like that, it can actually detect it with the help of its algorithms. So if we talk about different types of algorithms, just as I told, there is supervised learning. It can be classification tasks where it is labeling the attack as malicious or benign. It can be also regression, where it is learning from the previous data and predicting the next move or attack of a hacker or such attacking entities. It can be unsupervised, where it has some clustering, where it can group type of attacks, right? And it can also be a reinforcement learning, where it has real-time integration, and it is a reward-based learning. Basically, if it predicts the attack, it would get rewarded, and it has more attributes, so it enhances. But if it doesn't predict, it gets a punishment, or maybe some points are deducted. So that's how it keeps on learning. This is how we learn too, right? So what are some challenges and ethical considerations? So I would like to ask you guys, what do you think are some challenges that AI can pose? And should there be AI for ethics? As in like, what if AI gets everything, access of everything? Isn't that quite dangerous? The protector becomes the destroyer. What do you guys think? Uh, Anyone would like to answer that? Okay, cool. So there are some data privacy concerns, like will AI follow the GDPR that normal institutions follow? Because AI can bypass those things. So who takes the responsibility? The creator, the operator, or the AI itself? So that is where accountability, the question of AI ethics comes in place. And there is constantly a number of plans and proposals being imposed by US and like other entities also on AI for ethics. As in, what if AI becomes sentient, or at some point of time it takes some decision that might be too harmful? So who takes the responsibility? That part comes in. And resource requirements, obviously. AI comes at the expense of resource, like there are GPUs, there are servers where you have to host it, and obviously it would require those hardware resources to train the model. So that comes at an expense, obviously. Risk of over dependence, just as I told. For example, if you become over dependent on AI, so what if AI takes a wrong decision? So we need to have some human in the loop, so that if he monitors this AI's activity continuously, so that to ensure if AI goes uh, berserk, or AI goes over some limits, so that can be controlled to extent. And ethical consideration are algorithm and bias. Like what if the data you're training the AI is biased towards a specific type of attack? So it becomes a problem of overtraining, yeah, overfitting. So in that case, it might be able to detect a single type of attack, but bias towards that attack would be much more. So that might create some problems in the algorithm. Again, transparency. AI is a kind of black box, right? We don't know actually how it specifically detects the threats, right? We can't actually go into depth of it. For example, say Chat GPT. Do we actually know what these algorithms are built upon it? We don't know. It's like a black box, right? How can we find it, right? How can we know it? That's the OpenAI team. We have to trust them, right? And autonomous response actions. What if AI does a mistake and it allows some threat to bypass our system by not flagging it? It means the AI is at mistake. So that's a point where autonomous actions can be harmful without a review of some human. And then AI powered cyber attacks. As in, if we are using AI for security, obviously some smart people would also use it for cyber attacks, which is actually being used, right? So in that case, it's again a battle of virus and antivirus, just like I told. We have to find some secure ways where we can counter this type of AI cyber attacks. And it can be only possible by integrating a better AI system into our corporations. So this is a meme. I guess you might have understood this meme. So like in this image, Anakin says like we have uh, plugged ChatGPT into a classified network. That means there is some internal private network, a classified one, a secure network. We have plugged in ChatGPT into it. So uh, then also you have fixed prompt injection and the reaction. That means basically the chat GPT can access your classified network, and for example any third person from their institution can actually reverse engineer this, because there is no protection of data. There is no protection against prompt injection. In initial days, when ChatGPT was not ensuring that much level of security, that it was allowing jailbreaks, it was allowing things like prompt injection, where people can reverse engineer and maybe tweak in that ChatGPT. But nowadays, it has brought in some features where that is not possible. Still, if you are good at prompt injection, you can still find a way to bypass it. So that's where threat of transparency and security comes in. What if your data is compromised by the AI? So also there was a recently last week there was some paper released. Uh, in that paper they were talking about machine unlearning, not machine learning, it's machine unlearning. So what that does is machine or LLMs are actually given the data, but the sensitive data, which is like private to the organization, that data is hidden. So all the training over that data is basically reversed. So the AI or the model does not have any intuition over that data. So that's what machine unlearning is, to make sure the private data or classified network is secure. Open source tools for AI security. So in this, as I know, like Meta has introduced Purple Llama. So it's a type of project where we are developing open source tools for securing Gen AI. So like generative AI again is a boom, like Chat GPT, Gemini and all. But when you're plugging it to your network or doing some sensitive task on it, so we have to ensure there is some kind of certainty or transparency. So that's why this Purple Llama project ensures that. So you can just fine tune the LLM. For example, take Meta's LLM Llama. You can just fine tune it on your specific data, classified network, and have such a regulatory framework where it does not access your private data into their servers or into their databases. So this is where they are trying to build some kind of a transparency, so we can develop a safer generative AI. So why adopt open source tools? So as you know, like a lot of security firms uh, invest a lot in security tools. As you can see the meme right there, they are spending so much on a tool, but yeah, no one is using it, right? So what you can do is, why not adopt open source tools where there is data transparency? You can just dig into the code and see, okay, what's there, right? There is no vendor lock-in, so you're not like I have to be with this vendor. You can try out different things. As there is no vendor lock-in, it's again cost effective. It's open source software, and you can also collaborate on stuff with other security related firms. It's also better for your learning and skill development. So I will be going through some open source AI tools that are like mostly security based. So intrusion detection, as we say, like for example, if someone is trying to get into a private network through some attacks. So like what they are trying to do is they are trying to intrude your network. So it can be like you have a network, you have some firewall set, but yeah, they somehow bypass the firewall and they get into a private network. So how can we detect that? So there can be behavior-based anomaly detection. Like this intrusion can also be from an outsider as well as from an insider, because the bigger threat is from the insider, right? A lot of big security firms have been compromised in the past because of these type of intruder attacks from the insiders. So we can just check the logs and like activity of the outsiders as well as insiders on the network, and find like if there is some deviation from the normal behavior. If there is some slight deviation to that, it can flag the user. And there is real-time traffic analysis of the network packets coming in and all stuff, packet logging and detailed inspection. So like if someone is covering that with some malicious stuff, so we can detect it. And obviously AI enhanced threat detection, wherein we get a dashboard, as you can see, where it is continuously analyzing the points, the packet routing and all stuff that is inside our network, that is through our network. Yeah, and there is next post for vulnerability management. I guess many people use GitHub here, right? So does GitHub provide some security features? Yes. How many of you have used Dependabot or have come through it? Yeah, right. So what Dependabot does is it's GitHub's default, right, for security. For example, if there is some vulnerabilities that has to be fixed, you configure Dependabot, and like it's a pretty good tool for managing these vulnerabilities. So similar to that, this is a more advanced level of tools, next post. So it assesses risk based on AI powered algorithms, may it be clustering or may it be classification. And then there is comprehensive vulnerability scanning. It gives you a dashboard of lot of things, and real-time monitoring, which is more efficient because attacks can happen at any point of time. So monitoring real-time and getting notifications about any deviation or any such anomaly in your system. And it gives a comprehensive report and analysis, which is very helpful for the person to judge what's happening on my network or in my system. As in, it's much more easier to see the charts and data rather than I would like to see some packets or some CLI stuff because that's difficult to interpret, right? And SIEM, which is again security information event management, one of the key areas of cyber security. So there is this tool known as Vazu. Even I came across it yesterday only. So like it gives a centralized security dashboard, and again it's for the security information like infosec part of the organization where it goes to organizations all databases servers logs and everything and gives you a comprehensive security report of that. And if anything detected as in a malicious, maybe there can be stuff like some malicious back payloads वगैरह, so that it can detect and it is scalable. So yeah, again such type of AI tools are there and they are open source. So yeah, you can just go in, try. So let's do a quick drill again. So like phishing is again, the most common type of attacks that happen. Sometimes we are able to detect phishing, but again, sometimes we are not able to detect phishing, right? Because sometimes there are again smart people who can uh, yeah, create an illusion and again map it in a such a way that humans can't detect if it's phishing or not. For example, there's steganography where people can embed some malware into your image. How are you going to detect that? You're not going to scan every link, every image, right? It's just not possible for human, or it's just a tiring process. We are not AI, we are humans, right? We make mistakes. So there are some examples, you can read them. So it's about the real-time credit card frauds and social engineering example. So again, social engineering also a type of attack. So as you know, like where we use AI in security in real life. As you know, these are some of the most famous tools. Obviously, everyone might have used like the Microsoft Defender, right? What it does is you everyone know that there are a lot of memes on Microsoft Defender like it is not that good or it is not that efficient, but it still does a little like some compatible work. And there is Google's workspace email security. Like Google has this great AI feature where it can scan its email, it can flag malicious content, right? And then there is Twitter's content moderation. Like recently Twitter had open source this algorithm. So like this content moderation allows for like things like you might have seen a lot of blockchain based messages, you get some spam message. It's still not that efficient, I would say. As in like I also receive a lot of such tags from some airdrop or basically some BTC airdrop or some scam messages like that and DMs. But Twitter has restricted it and it goes basically into a spam messages. So yeah, continuously improvements are being made on that. AI is the need of hour in cybersec. Why I say this is again like as it's the age of AI, there are new AI algorithms, there's new research papers being published, new methodologies coming, I would say too rapidly. So in this rapid development, if we don't upgrade our traditional security measures and integrate AI on top of it, there might be some cases where AI can actually breach your system. So to fight against this AI, we need to have AI in our systems too, right? That is the only way how we can counter it. Yeah, thank you. Yeah. So do you have any questions? Do you have any questions? Yeah. Hmm. Yeah. Hmm. Yep. Yeah, I got your question. So basically, you are right to some extent. Like integrating AI is fine, but yeah, again, even AI can be bypassed. But what would you prefer? Being more probability of bypass or being less probability of bypass? Yeah, and as in like there are improvements constantly in the field of AI too. Like they are training their own models. Like before they were dependent on some third party tools or something. Like there are many organizations developing their own models, so it has a greater chances of transparency, right, and accountability because they are developing it. They know what they are, where they are, the data is going. And yeah, depending on the phishing wala thing, yeah, like people are adapting to more efficient ways of phishing, but again, the counter security measures are always updating, so there is an adoption rate in that. Anyone else? Yeah. Oh yeah. Yeah, I got it. Like, as in, you don't want to deep dive into those deep neural networks and all. You just want a simple type of AI which can work, right, or for your task, for example, pen testing. Yeah, like as I told, there are three to four types of levels. So the basic level is supervised learning, where like what it can do is it has some data, right, of the your pen testing stuff. So it can just create a type of learning curve where it has some basic algorithms like regression, which is not too complex. So you can use that, or classification, which is again not too complex. There's no need to go into deep neural networks and stuff like that. So yeah, for simpler tasks, you can use a low level of machine learning algorithms, a low level of algorithms. And as in you want to scale, you can use more upgraded ones like the deep neural networks or GANs. Yep. Ah, okay. Yeah, you have a valid question. Like, for example, if you're using an open source tool for your CM, and obviously in CM, like whole organizational data comes in. So yeah, that's where transparency wala thing is. Ki, are you accountable? That is the system transparent, right? So what you can do is, yeah, currently, for example, if you also use a third party, do you completely trust their process? Isn't it again like a black box? Because they won't be revealing exact structure of what they are doing. So you have to eventually trust the third party too, right? But in open source, at least you can see, I would say like some extent or more than that, the code is open source, so you can actually see what's going behind. And you can basically create your own, like it's like a white collar software. You can just take that open source tool, you can create your own on the top of it. So that's a way where you can counter this transparency wala thing, right? Any more questions? Yeah. Okay. On Microsoft Defender. Yeah, honestly, I don't use Microsoft Defender a lot. Like I have like Avast security. So, but yeah, uh, it does a trivial amount of tasks. Like if you are going to some restricted sites or blacklisted sites, it might like warn you before visiting those sites. But it does not do a more extensive task. That's why you require antivirus software like Avast or some other credible ones, because obviously you can't compromise your system. Yeah. Any other questions? Thank you, guys.
Where is Pratik? Has he left? Yeah. So basically, Pratik has covered 90% of my slides and made my life more harder. Now, I'm not sure what I'm going to present about because all the topics which he has discussed, it's there in these slides. Anyways, what I'll try to do is maybe explain some, scenarios which we are facing on a daily basis, the challenges, and some technical terms and all. So, move on. Yeah, just about myself. 13 years of overall experience, 11 years in cybersecurity. I am working as a blue teamer. So in this crowd, how many guys are from blue team? Blue team is basically the SOC, threat hunting, threat intel. Only one. Oh my god. Good, good. Red teamers from the offensive side. That's great. Thanks. So, nice to see that. Uh, I was also just thinking, to slowly transition to the offensive side because the best way to defend is obviously, you should know how the attackers perform their attacks, right? And I've decided, to collaborate with different security communities to share knowledge, to learn from you guys. No matter how much years of experience we have, every interaction is a learning, and I totally believe in that. More, please move on. Yep. This disclaimer is important because I'm not an AML expert, but we can have discussions. Questions will be taken. I am aware of it. I'll be answering it. Otherwise, I'll have to check and get back to you. I am not representing HDFC Bank. I'm on here on a personal front. I am working in cybersecurity in HDFC Bank. So, मेरा net banking नहीं चल रहा है, credit card not working. I'm sorry, I won't be able to help. Our bank will get in touch with you. Is all what I can say. Hopefully, you guys are not facing any issues. This presentation is prepared solely on online material. Nothing is proprietary. I've just given the references also of the links. Moving on. Yeah, so this is the agenda, and as I mentioned, Pratik has already covered it for me. What is AI? What is ML? Basic definitions, types. Why do we need AI/ML in security operations? How it is actually elevating cybersecurity? The AML-based prevention and detection tools and techniques. I mean, we had some discussions in the earlier session also. Security for AML is something that is needs to we have to start to discuss. We have to start researching because, as Pratik already mentioned, that is something that is going to be the future. Moving on. Yeah, so this is just English. What is machine learning? Why do we need machine learning? I started with machine learning because I believe it's a subset of AI, and from advanced machine learning, that's how AI comes up, right? Uh, it's a subset. It's a study of algorithms which analyzes large amounts of data, and the more data fed into machine learning algorithms, the more precise it becomes.
and that's how it gets improved also. Uh, it learns from past data, and that is actually a factor, right? We need to know the past in order to perform better in the future. Why we need ML? I guess also that's very pretty much clear. Uh, Accuracy of outputs, eliminate human errors. All these mistakes are far more than enough to describe the necessity of machine learning. Oh, yeah. Type of ML. These are the basic types which are available today: supervised, unsupervised, and reinforcement. Supervised machine learning is again basically labeling data and feeding it to the system. So you're telling the system that this is the data that you'll have to work upon, and its label, and based on that, the algorithms will give an output. Unsupervised, as the name suggests, there's no label data. You'll be working on what all data it gets. So there's a combination of both supervised and unsupervised in the term of semi-supervised, wherein some of the data provided to the algorithms will be clustered, whereas there will be unclustered, unlabeled data also. So that's something that is in progress and is being used in different tools. Reinforcement, yeah. Uh, Reinforcement, again, video games is a good example of reinforcement, wherein it is works on a feedback process, and as Pratik mentioned, it's a reward based. So whatever happens as part of the process, it'll provide that feedback. Why? Yeah. Next. Yeah. Coming to AI. So everywhere there is AI. There's so many applications of AI. I am 100% sure that people here are using ChatGPT stuff. One funny incident happened during my, I mean, it was very recent. One of my juniors in the team, he was a bit, lagging in emails, documenting emails, and all of a sudden he became an expert, and he was just writing mails like my MD. I was so surprised. I went to congratulate him, and then he told me, "Sir, ChatGPT है ना, टेंशन लेने का जरूरत नहीं है." He had ChatGPT installed in his mobile and he used that. No offense, but it's nice that people are using technology, but to what extent is the concerning part, right? So we can use AI for building machines, computers, bringing the more efficient part of it. One point that should be noted is, or is a misconception is that AI is to replace human beings, which is incorrect. AI helps human beings focus on what is required the most. Instead of getting involved in mundane tasks, repetitive tasks, you can focus on more other areas where human brain can be used for strategizing. Yep. Again, types of AI. We've seen types of machine learning. These are some of the types of AI available: reactive, limited, theory of mind, self-aware. Limited memory AI is something which you guys will be aware. It's more of the predictive and generative AI components. I guess generative AI, you guys are already aware. The LLM models, the GAN networks, all those Pratik has just mentioned. Examples of limited memory AI would vary in ChatGPT, BARD, Deep AI. A theory of mind AI and self AI is something that is in an upcoming stage. You might have seen it in movies. You might have seen the movie, the Rajinikanth movie Robot. City is an example of theory of mind AI, wherein emotions are also instilled into AI algorithms and they react accordingly. So dangerous, but it's something that is in the progress. Yes. Now, coming into the topic of why do we need AML in cyberspace? So we all know that attackers are shifting to automated type of attacks. The attack surface is growing large. The cyber skill set is also an issue in today's world. Lack of insights, too much of information. So working in a bank, I'm so much aware of how much of data we have to work on a daily basis. It's so much of overload of data because there's so much of applications different attack services, uh, processing that itself is a huge task. So that is also a challenge. Now, when we bring in AIML, we are so how we are trying to utilize it. Basically, is what we just mentioned earlier. The the repetitive tasks should be processed more efficiency. Uh, all those would be the use cases for bringing in AML in cyberspace. Reducing the triage time, speed investigations, all these are use cases which we, from a security operations perspective, would be looking forward to. Moving ahead. Yeah, how it's elevating cybersecurity. Again, this is something which has already been discussed. I'm sure you guys are already aware how machine learning works. There is a concept called behavior modeling, wherein patterns are actually uh, analyzed, and based on those analysis, if there is a deviation, then an anomaly is triggered. So that happens because of behavior modeling, and once the behavior is set, any event or any activity which is different from that will trigger an anomaly detection. Uh, Time intensive tasks to reduce it is always going to be helped, and I'm sure people who are working in the operations will agree to this. Threat identification, classification, risk scoring, some of them are automated as of today, but when AIML comes into the space, it actually helps to enrich it more further as of today. Yeah. So this is just a uh, use case of how the advantage of using AI and ML. People who are working in operations would be aware of the concept wherein the security operations. So, is anyone not aware of what a security operations center doesn't do? Any doubts, or are you hearing it for the first time? I hope you're already aware. Yeah. So we at the Security Operations Center, we have to do 24 by 7 monitoring. We monitor different device types like the endpoint devices, your network devices. Events are collected from these devices and they're being monitored. So on a daily basis, there will be at least billions of events in large enterprises, and from those events, there would be alerts that are triggering. This is on an average 11,000 alerts per day. Uh, if a SOC team has to analyze this many alerts, then uh, just imagine the difficulty from a human perspective of how. I mean, it's not even possible to monitor more than 20, 30 alerts in a shift. Forget about 11,000 alerts in a day. So that's wherein AI could come in, divide it into two sections. One is the automated alerts, and some of the alerts wherein human intervention is required. So this is the statistics. An example wherein it's mentioned out of the total number of alerts, you have 73% that is automated, and the remaining 27 may not be determined at that point of time. It might require manual intervention, and then based on that, you will escalate it for further operations. Reducing the attacking. So you guys are aware, right? I mean, how much time it takes to respond to an attack, or in fact to identify an attack. It's in days now. It's at least 100 days or 250 days. Bringing that time down. That's one application of AML. How it does is something that goes in deep. We may have a separate session for that. But on a high level, this is one example which I would like to discuss. Yeah, moving on. Yep, different. We already saw the different types of devices that are generating events and sending to an security operations center. What are those areas? Basically, the endpoint, vulnerability and patch management, identity and access. All these areas is where we would require enhancement in the form of AIML. Threat simulation. How many of you guys are aware of what threat simulation is? Any idea threat simulation and why it is important? Sorry. Okay. So basically, from a blue team perspective or security operations perspective, uh, we would have to equip ourselves with the latest threats, the latest attack vectors, right? If we have tools wherein threats can be simulated, that will be lessons learned, or will be a huge learning for the team, and we have tools for that. So rather than humans getting into for performing simulation exercises, if we have it through AML based tools, that will be a huge bonus for the teams. For the teams who are actually detecting the alerts, because the detection teams are not that capable of actually performing attacks, which is also a requirement. SIM is one tool which we have already discussed today. The AML intervention for SIM is actually helping a lot. We have just seen an example wherein it brings down the number of alerts where manual intervention is less required. Threat hunting, again, domain within the blue team, wherein humans actually run queries along different events from different devices to identify whether there's any possible threat scenarios that are being covered. So this is where AML can be applied across cybersecurity domains. Moving ahead. Key takeaways. I know it's a bit statistical, but to be frank, since all the applications have started using AI, in fact, the organizations have already implemented AI in their applications as well as security operations also. We are in either in a stage wherein the security tools have either implemented AI or is in the process of evaluating different tools of going for an advanced set of tools which use AI in their detection purposes. This there are companies wherein they show the return of security investors, ROSI, because at the end of the day, uh, when cybersecurity is part of a huge organization, it may not be providing revenue to the organization, but it's a domain which requires huge investment. So showing the returns of that investment is a critical part. Those who are not joined the industry yet, it's a lesson learned for you. One day you will have to show your returns on the investment being made on all these security tools. So bringing in AML is actually increasing the returns of security investments, and it's also reducing the data breach costs by 18%. Yeah, more. Well, till now we discussed about AML for security, how we are using AML for security detection. But what about the other way around? Do we have to secure AML? So when we're using AML for detection, obviously the offensive, the adversaries will have already, utilized AML, different AML technologies for performing the attacks, right? But what about the AML techniques which are being used by organizations for detection purposes? In that case, uh, adversaries will also try to understand what type of AML models we're using, how they can manipulate it so that it gives incorrect predictions, which will actually lead to a chaos within the application or the organization itself. That's something that needs to be discussed in length, and it's something that's getting evolved. There's no framework for AI. I guess NIST has just whatever. I hope everyone is fine. Yeah. This has just brought up a draft framework. It's still in work in progress. Uh, Regulators, the government entities are all working for AML based frameworks. We don't have any, uh, you know, approved document just as the same in blockchain also. We're struggling for that also. So as I mentioned, since attackers have started performing on the AML models, that is going to be the future for detection of from a security operations perspective. Yeah, some of the common attacks that I've just gone through research is evasion attacks, poisoning, prompt injection. Prompt injection was just discussed earlier, wherein you have an interface like a chat GPT, and if you inject into the prompt window a code and you get information which is actually not supposed to be viewed. Sorry, am I audible? Yeah, which is not supposed to be viewed by the user, then that's basic classic example of prompt injection. um, Privacy attacks, wishing. If you guys are not aware, it's like you call the user, you ask for information, and then based on that, it's just a social engineering technique basically. Just imagine, as of today, we get calls. We are asked for information over calls that is by humans. But just imagine when it's automated, and it could also be from people who who are actually not doing that. So that's also a very scary scenario. Authentication bypass is also something that is going to be a problem moving ahead. Already, identity is a huge area which is being impacted on a daily basis. So that is also something that the attackers will be concentrating on. Yes, I just gone through it quickly because, as I mentioned, most of the topics were already discussed. Any question from anyone? Sorry. Yeah. So wishing is basically a social engineering technique. You pick up a phone, you call the user. So like phishing, it's through the mail. Wishing is through the phone. You call a person, you ask them for the details, you lure them to give the details of your financial details or your other contacts. That's all wishing. Questions? Yeah.
Okay, okay. Very important. So, uh, one question which I have, what is the topic of something called alert? So, which is a lot of topic of at the same time. Because maybe one small vulnerability which is allowing lot of different verticals. So, I think that there are certain AI tools which can, if you could just suggest a tool which you have gone through or something like oh, I just would like to know more.
Yeah. So basically the question is about alert fatigue and how we are countering it. So as of today, security operations centers have the leverage of adopting to AML based SIM tools, wherein as I mentioned in the slide earlier, they will be a part of, for example, am I audible properly? Yeah. So there will be some percentage of alerts that can be automated. Like I'll give a daily example which we face. Uh, we have compliance requirements. There will be alerts wherein we have to just check whether it is an authorized activity or not. So that part is currently being manually done, but that is something that can be completely automated using playbooks. We have tools like security orchestration and automation response tools, which can be used to develop playbooks so that some part of that the overall alerts triggering on a daily basis is automated. So now the ecosystem is changing in a way that the SIM, the SOAR, all these tools are being combined with one single platform, so that the graph which I mentioned, wherein the number of alerts on a daily basis, there will be a set of automated alerts which will be directly enclosed with playbook designed accordingly, and there will be very less amount of alerts which the analyst will have to manually work upon. From open source perspective, I guess Alien World is something that has this feature. I'm not sure, to be frank. Unfortunately, working in SOC across all the companies, we didn't have the leverage of working on open source. We had to work on licensed tools. Any other questions?
Actually, I was working for, and this is also very currently we deploy
which is AI based, and then on the vendor side, for the initial stages we get a lot of false positives. How long does it take learn from AI to teach the AI that these alerts are false positives and you should not display these, you should like directly close them. And these are the alerts which you should show the analyst and then you should like rectify on them. So
Yeah, so we discussed about machine learning techniques, supervised and unsupervised, right? So in supervised learning, it actually mentions that it's labeled. So in your example which you mentioned, if we are already aware that it's vulnerability scans that is being performed within the enterprise, we can actually label it. We can feed the system the data saying that these type of scans will be authorized, and anything apart from that is an anomaly. So there is a pattern that is observed. Usually in enterprises, these vulnerability scans are scheduled. Rarely they would be ad hoc, and they would be, static IP addresses or systems that are used for scanning. All these are known information to us, can be labeled, and can be provided to our machine learning model saying that this is known activity. Anything apart from this is an anomaly, and that will help us to reduce the false positive. Hope I answered your question. Any other doubts? I know everyone is tired. It's almost lunchtime. It's a Sunday. How many of you guys are having a holiday tomorrow? Yeah, same bench. Me too. So if no more questions, thanks a lot.